Here we are in a 2012 or 13 AEV JKUR Rubicon. We have a 6.2 L86 in this Jeep, and it's raining. This Jeep was built actually a long time ago. I'm going to say close to 2 years ago. But this Jeep used a 2015 powertrain that was supplied by the customer. As we discussed earlier, some of the earlier 14 and 15 transmissions had some issues. Now, it shifted and ran great, but GM has implemented a lot of improvements, especially for the shift quality. So he brought it back, and we've updated a lot of things, not only in the transmission, but a lot of the things that we've learned over the years with these Gen 5 swaps. And the learning curve for the Gen 5 swaps is pretty much flattened out. We know a lot about these now that we have dozens of them under our belt. This JK right now runs as good as any of our current builds, and it's taking advantage of our current technology and software. This transmission now shifts awesome, and it still is a 2015 operating system. We've applied some of the new GM software and hardware, and we've implemented some new firmware updates to the MOCAN module, so tap shift and cruise work. In fact, let's go into tap shift here. See, we're in 5th gear. If I want to bring it down, 4th, 3rd, you notice the RPM match shifting. 5th, go back into drive. Cruise control. Turn our cruise on. Engage it. Now we're in cruise. I'm increasing our speed. Now what I'm going to do is I'm going to actually go back into tap shift while we're in cruise, and you can see we maintain that speed even if I bump shift. Now I got to stop because of traffic. So with all these upgrades, we're going to take this Jeep to the mountain tomorrow, and I'll give you some feedback on this early 2015 Cadillac Escalade L86 LT 6.2 with an 8L90 8-speed transmission. It's a cold, wet morning here in Las Vegas. Let's see how this Gen 5 L86 starts. One of the issues they had with the early Gen 4s was air fuel management. Air fuel management works by hydraulic oil pressure collapsing lifters so the cam can go up and down, but the push rod doesn't move. That turns the cylinder into an air spring. So what happened was, if those lifters got over pressurized, they would fail. And in the early Gen 4s, what GM learned was they had to add an additional oil pressure regulator in the oil pan to keep the oil pressure under about 75 psi in a cold start. Now, it's about 46 degrees here in Vegas, but if you were sub-zero temperatures or even below freezing, and you had heavyweight oil in your engine, and you didn't have that additional regulator, there was a chance on a cold start you could damage a lifter. GM had similar, if not the same, issues with the early Gen 5s in 14, 15. They did correct the problem. They did come up with replacement components at an affordable cost to repair your AFM. It essentially involves replacing the lifter manifold assembly and the lifters. But by 16, 17, the problem was resolved and there is no more issue. Same thing happened in 7 and 8 with the LSs, like I said, and by 10, the things were very reliable. So we're driving a 15 right now, and most of the 15s that we've done have not had any issues with air fuel management. It's mostly been with the transmission tuning, and mostly has been correctable with software updates. This particular vehicle had a hardware problem in the transmission that had to be corrected, but now that it has been corrected and flashed to the latest firmware, it drives excellent, just like the later model 17 LTs that we've been doing. So I guess the moral of the story is it did take GM a couple of years to sort things out. If you get an early model LT 14, 15, 16, don't worry. It's not expensive and pretty easy to apply these corrections. If you get a later model LT, they're pretty much sorted right out of the box. And I really can't tell the difference between this early model 15 and the 17 when it comes to drivability. They both run excellent. I will say when the 8L90 is working properly, it's top of the line in the engine swap world. Not only is it strong, but it shifts excellent. In the early days when the 8L90 was herky-jerky and GM was sorting it out, I think I preferred the 6L80. But today with large tires, especially if you live up in the mountains or you're going to tow, there probably is a slight advantage to the 8L90. Don't look away from the 6L80 though. The 6L80 is still an excellent transmission. The 6L80 still has diverse gearing and is very strong. The 6L80 is also a clutch-to-clutch adaptive transmission, so it is modern. It's low friction. It's not like the early 4L60 and 4L80s. The 6L80 is still a very viable transmission in both the LT and the LS swaps. 8-speed gives you that little bit of an edge if you got large tires and you want to launch hard. You get a 4.6 low. It's got a slightly taller high gear, so if you ran shorter gears, and the Jeep we're in right now, one of the issues that we actually had and something we should discuss is the gearing. These LTs are really designed around torque management, and most of you know that's kind of a bad word when it comes to programming, because when you're working off of torque management, you're working off of calculations that are made on the fly and coefficient based tables and just all this stuff that comes into play. It's not like the old days where you could just basically say shift at this speed with this pressure. This torque management based operating system shifts based on torque output of the engine. So if you change any of the coefficients in that formula, you're going to change the way this transmission shifts. And one of the issues with this vehicle is the fact that it has short gear. What the LT wants is to use the available torque that it has down low, and it has a lot of torque. So if we look at what GM does, we could be talking a 6,000 pound Suburban with 321 gears. Now, y'all know that that's not what we do. We're running 6,000 pound JKs with 37 to 40 inch tires. So what we have to try to do is mimic the torque applied so that this transmission shifts properly, and we've learned a lot about that. And I would say that was probably the steepest learning curve in getting these Gen 5s working properly. Now GM has also worked right along with us parallel in making the adaptive portion, and what that means is these transmissions they learn volume indexes. There's actually something called a transmission characterization, and GM flow tests the solenoids in these transmissions and apply a characterization code to the side of the transmission. So when you flash that transmission with GM software, it flashes in essentially the brain, not just the brain, but the information that the brain needs to shift properly. And all that information revolves around the OE vehicle that it was installed in. So when we put this in an aftermarket vehicle, it can be challenging, but not so much anymore. GM has got the adaptive learning down to where we can install one of these and they learn pretty quick. There's also a quick learn procedure that you can apply. So when you get a really heavy JK under a really heavy load, it kind of changes the game. Yes, you want a lot of horsepower, but horsepower is not really what moves you. What moves you is torque. This engine, if you look right now, unless this guy has a custom gauge cluster we installed, we're idling at under 500 RPM with this LT. This LT will cruise at 80 miles an hour, and I remember back in the 1980s working with the throttle-bodied engines. Well, I even go back before that, back in 1976, working on the first closed-loop systems in the old Cadillacs with the Bosch injection, and then when fuel injection really became popular in the 80s, the K motors with throttle bodies, that was a huge improvement. The problem was wall wetting, because we're putting the fuel down the intake manifold. By putting it into the chamber, which direct injection does, of course that's the best. Ford actually experimented with that, but we just didn't have the technology to implement it in production. So we put it behind the intake valve, and when we started off in the early days with digital injection, meaning it really wasn't, it was computer controlled, but we didn't have closed loop feedback. And then of course we added closed loop feedback to fuel injection, just like we did with the carburetors. Some of you guys might remember the old Rochesters and others that went click, click, click. It had the mixture control solenoid, and that was pretty good. Then in 1996, when the feds required misfire detection for OBD2, that's onboard diagnostics, we had to go to sequential fuel injection so that the misfiring cylinder could be identified, then the fuel shut off to that cylinder. Because basically failure modes required by the US EPA went from going rich to going lean. What that means is if you had an older engine, you had an injector go bad or a fuel regulator blow, the engine would go fat. And they were trying to avoid that. So when you did have a failure mode, they wanted it to fail lean so you weren't a gross polluter and damaged your catalytic converters. There's all sorts of stuff in the background most of you guys may not know about, maybe some of you do. And this is the direction that we have always pursued, because we're trying to keep all this stuff active. And by going to hot rod tunes, hot rod calibrations, and harnesses, what you're doing is you're losing a lot of that functionality. If you got this technology available to you at the price that it's available, you would be foolish not to take advantage of it. I've been a hot rodder for 40 years, and what we're doing right now is just simply amazing to me. I remember back in the day trying to get 400 horsepower out of a big block Chevy and keep drivability was a challenge. Today we're getting 400 horsepower out of engines that idle at 500 RPM and get close to 20 miles to the gallon. Back in the day, if we broke 10, 12 miles to the gallon, we were happy, and if we drove through a drive-through, your eyes would water, so you had to shut the motor off. So in today's world, if you don't take advantage of this technology, in my opinion, you're being foolish.